Alright, so today we've got 3.6 day 2, dealing with that quadratic formula again and just some different kind of situations with it. So this first one here, just to get back into what we were talking about, remember that quadratic formula, we've got x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we're working with that similar situation here today. In this question, round your answer to the nearest hundredth. So here you're going to need to be actually taking that square root of that number when we get down to the end. We'll talk about that when we get there. So in this situation, when we've got 5x squared plus 3x equals 3, remember we need to be in that standard form of ax squared plus bx plus c. So I have to get everything over on one side of the equation. So I'm going to subtract 3 from both sides. So it cancels out on the right, and then I'm dealing with 5x squared plus 3x minus 3 equals 0. That's what I want for my standard form in order to be able to actually get an A and a B and a C now, okay? So when I'm here, I've got an A of 5, a B of 3, and a C of -3, and we can kind of see that again up here with everything in the screen. That's our A, B, and C, and now we're just plugging things in. Okay, so now my quadratic formula is going to say x equals the opposite of b, which is going to be -3, plus or minus the square root of b squared, so 3 squared, minus 4 times 5 times -3. And we're all over the fraction 2 times 5 on the bottom. Okay, so as I extend this down, I'm now, I like to do this chunk first. So 4 times 5 times 3. So first of all, 3 squared is going to be 9. Okay, so I've got 9, and then 4 times 5 is 20. 20 times -3 is going to be -60. Okay, so I've got 9 minus -60. Well, minus a negative is addition, so I end up with 69 under the square root. So what I'm going to be looking at is x equals -3 plus or minus the square root of 69 all over 10. Excuse me, that 2 times 5 is going to be 10. Okay, so this is kind of what we did yesterday. The next step we just touched on right at the end of yesterday's notes. But when they ask for a rounded answer here, round your answer to the nearest hundredth. So they don't want the exact answer in terms of square roots in that radical form. They want you to actually take this square root. So when I take the square root of 69 here on my calculator, what I'm going to be ending up with is going to be, whoops, I did that wrong. Okay, it's going to be 8.30662 and on and on and on. Okay, so when we round that to the nearest hundredth, I'm going to end up with 8.31. Okay, approximately. That's what that squiggly equal sign looks like, or that's what it means. So what I've got right now is x equals -3 plus and minus 8.31 all over 10. Now, when I've got that, okay, when I'm at this point, with square roots, we just answered it this way. When I've got now all some form of a number, even decimals in there, even though we rounded it, I can go a little bit further with this. I can break this into plus, which is going to be -3 plus 8.31 divided by 10. And I can also do the other one, which is the subtraction in there. So -3 minus 8.31 divided by 10. Okay, so just to get those final answers here, I've got -3 plus 8.31, and then divided by 10 is going to give me 0.53 when I round to the nearest hundredth, excuse me. And then in green, I'm going to get negative 1.13 when I round to the nearest 100. So those would be my two solutions here. Once I've gone all the way out to the decimals. Okay. Next one. So what we're going to find out here, we've got some complex solutions. That's a little hint. So we're already in standard form, so we can go ahead and put that into our equation. So x equals the opposite of b. So b is 1 right now, so the opposite of b would be negative 1 plus or minus the square root of, so b squared is 1 squared, minus 4 times 2 times 6. And that is all over 2 times 2. All right, so that is my quadratic formula right now. Okay, so now I go ahead and I take care of the discriminant. Okay, 1 squared is 1, minus 4 times 2 is 8. 4 times 2 is 8, and 8 times 6 can be 48. So 1 minus 48. Okay, so I'm actually ending up with a situation here, that's negative 47, where I have a negative number under the square root. So I have x equals negative 1 plus or minus the square root of negative 47 all over 4. Okay, this is that complex number they're talking about. This is with the imaginary numbers. Okay, you're going to run into situations with imaginary numbers and some of this stuff. So remember, if we can, we want to factor this. Well, the only factoring we can do here is taking the negative out of that square root situation. So back to what we did in 3.3, this is the square root of negative 1 times the square root of 47, and the square root of negative 1 is I. So we've got I root 47 here. So really what I'm looking at with this quadratic is x equals negative 1 plus or minus I root 47 all over 4. That's going to be my solution right now. Okay, this is getting really intricate here, for lack of a better term. We're getting complex. Get it? Because it's a complex number? Yeah, I know. Okay, so once we're at this point, just make sure when you enter it into ALEKS, they're not asking for us to do this in a rounded answer because you can't take the square root of a negative. Just make sure that you're entering this as negative 1 plus I root 47 over 4 and negative 1 minus I root 47 over 4. And those would be your two solutions here, and that's how you would type them in on ALEKS. Okay, so that's where this, that's what these problems with an I and I value involved are going to look like. Now, the last one I'm going to do for you guys is you're going to run into a word problem on this homework here. You've got a quadratic, okay? So a ball is thrown from an initial height of 7 feet with an initial upward velocity of 31 feet per second, and the ball's height in feet after t seconds is given by the following. So that h represents height, and then the t are your variables here, okay? So this is actually exactly what this is used for. This quadratic function, this quadratic formula are used a lot. And this is a real life situation. Now, how often are you going to measure throwing a ball up in the air? I don't know, not very often. But when you see things like rockets, you take lift off, they're going to follow a similar kind of arc up and down. Those are these quadratic formulas. These are very real life applicable things, okay, in a lot of physics situations too. So this is where you get into kind of maybe the more interesting part of it, where you see that this is actual measurement of these things, okay? That negative 16t squared, that's gravity, all right? Anytime you see a problem where you're talking about throwing something up in the air and it's coming back down, you will always see that negative 16 as that first value out front of the t squared. Now, something I want us to be careful with here, first of all, you're plugging in this 21. They're asking you the question, find all values of t for which the ball's height is 21 feet. So you're plugging this 21 in for h. So what you're dealing with right now is 21 equals 7 plus 31t minus 16t squared. Well, first of all, you want to get everything over onto one side, like that standard form we talked about. So I'm going to subtract 21 from both sides, and it's going to combine with the 7. So now I've got 0 equals negative 14 plus 31t minus 16t squared. Now, a mistake that we see a lot of people make right now is they're going to tell me that my A is negative 14, my B is 31, and that my C is negative 16. That is incorrect. And if this were a presentation going on here in class, I'd ask you why. But right now, I just have to tell you the fact that this is not yet in standard form. Okay? You don't pick your A, B, and C just based on what's first, second, and third. Okay? You pick your A, B, and C based on what they're attached to. So we have to make sure we are actually in standard form, which is making sure that your t squared term is coming first. Okay, so we should actually be looking at 0 equals negative 16t squared. Your t term is coming second, plus 31t, and then that constant is coming last, minus 14. Now you've got your A, B, and C in the right order. Okay, from left to right, now you've got your A, B, and C. So your A is actually negative 16, your B is actually 31, and your C is negative 14. So make sure you don't make that mistake, okay? Once we're here, we can now plug this in to the quadratic formula, okay? So I've got x equaling the opposite of b, so negative 31, plus or minus the square root of b squared, so 31 squared, this is going to be a big number, or you're going to be working with big numbers, minus 4 times negative 16 times negative 14. Okay, a lot of big numbers going on here with what we're doing in this problem, all over 2 times negative 16. Okay, so let's just get some of these pieces here spread out with the multiplication. So the first thing I'm going to do, so 31 squared, 31 times 31 is 961. Okay, and then 4 times negative 16 minus times negative 14. So 4 times, so that's all going to give me 4 times negative 16 times negative 14 is going to give me 896. So what I end up with here now is x equals negative 31 plus or minus the square root of 961 minus 896. Remember, it's subtracting because we didn't do anything with that minus. It's still sitting in there. All over negative 32. Okay? Well, 961 minus 896 is going to be 65. Okay? So inside here, we've got 65. Now, what they're wanting you to do, round your answer to the nearest hundredth. So when we see that we've got the square root of 65 going on here, we need to take the square root of 65 and round it to the nearest hundredth, which when rounded is going to be 8.06. So right now I'm looking at this. Negative 31 plus or minus 8.06 all over negative 32. And this is when you're going to split this up into two different scenarios where you're going to add one and subtract the other. Okay, so now I've got x equals negative 31 plus 8.06 all over negative 32. And then I've got x equals negative 31 minus 8.06 all over negative 32. Okay, so just give me a second here to do these on my calculator. So this first one is going to be rounded to the nearest hundredth. It's going to end up being 0.72. Okay, and the second one rounded to the nearest hundredth is going to be negative 30